Now, we are going to start types of cement. Cement, as we told in the last lecture, in the last slides, that cements can be broadly classified into two types: hydraulic and non-hydraulic. In hydraulic and non-hydraulic, and these are the types of the cements classified by the BIS. So there is the first one is the ordinary Portland cement, then second one is rapid hardening cement, then extra rapid hardening cement, low heat Portland cement, Portland slag cement, Portland pozzolana cement, sulfate resistance Portland cement, white Portland cement, colored Portland cement, hydrophobic cement, high alumina cement, super sulfate cement, and special type of the cements. Before we are going to start the types of the cements, it is very important to know that in the present scenario, we all are at the alarming edge of the global warming, and cement is also responsible for the CO2 emission. Because of the manufacturing of the cement, there is a huge amount of CO2 emissions. So, but we all are trying to reduce that CO2 emissions by using different types of materials which have high content of alumina and silica, because as we have already covered in the slides, in the chemical compositions of the cement, that it has a high content of alumina and silica. So that is the major role in the alumina and silica in the cement. So, and it is also a fact that India is the second leadest in manufacturing of the cement, production of cement. First is the China, which is a higher production manufacturer of the cement. So first is the China, and second is the India in the production of cement. In the production of the cement. Now, after that, we are going to discuss all of these types of cement one by one. So, first we are going to discuss the term that is ordinary Portland cement, and later on we are going to discuss all of them. As their name says that it is a ordinary Portland cement. Now, let's come to this ordinary Portland cement. It is also written as OPC, and this type of cement is come in three grades: 33, 43 and 53. Okay, and we have different IS code for all these. Now the thing is that how it will be obtained. It will obtain by the pulverizing argillaceous and calcareous materials in correct proportions. Then it becomes a ordinary Portland cement. So it is a combination of pulverizing argillaceous and calcareous materials. Now what the numbers shows, as you can see that there is a OPC grade 33, OPC 43 grade and OPC 53 grade. What these numbers shows? These numbers shows the characteristics compressive strength of cement after 28 days. It shows compressive strength after 28 days. When we are going to use OPC 33 grade cement, it shows their compressive strength after 28 days. Same as 43, after 28 days it shows 43 compressive strength, and after 53 and 53 shows compressive strength after 28 days with obtained as a standard test on cement and sand mortar. Now what are the uses of this? Now OPC 33 grade is recommended for the mix having strength of M20, and it is the most used cement in the construction industries because it has no exposure to sulfate, means for the durability properties. It is not clear here, so it shows a durability properties. It shows the durability properties. So that is the ordinary Portland cement. Ordinary Portland cement is very widely used in the construction era, in the constructions of the different types of structures, as well as in India it is widely used. Now next, move forward for the next type of cement, that is rapid hardening cement. In short, it is known as RHC. It is also denoted as RHC. It, as its name implies, it is provide rapid hardening. It provides more hardening than the OPC. So it is finer. Yes, there is one more thing, that it is more fine than the OPC cements. Means it is more finer. As if we are going to do the comparison, OPC in rapid hardening cement, it contains more C3S and less C2S, and in OPC it contains less C3S and more C2S. And the 1 day strength of the cement is equal to the 3 days of the OPC. Means when we are going to finally make a final product, that time the strength of 1 day rapid hardening cement is just equal to the 3 days strength of the OPC. Yes, means रैपिड हार्डनिंग सीमेंट की स्ट्रेंथ जो 1 डे में होगी वही सेम कंपोजिशन से ना इसके जो होगी वो होगी आपकी 3 डेज में जो स्ट्रेंथ होगी ओपीसी की उसके इक्वल. नाउ yes, the main advantages of rapid hardening cement is that the shuttering may be removed much more easier. So if we are going to use rapid hardening cement, then we can remove the shuttering as earlier, and as if we are going to remove that earlier, so it will save the time and the expensive. So it is somehow it is a cost effective, and as well as it provides a more hardening to the structure. More, not in the terms of more hardening, it will provide the rapid hardening to the structures. But the cost of this cement is nearly 10 to 15% more than the OPC. Just because of that, because it will have the different proportions, so the cost will also increases accordingly. It can be safely exposed to frost as it's mature more quickly. So it doesn't have too much effect of the environmental conditions on it at the Now, next move forward to the extra rapid hardening cement. It is more advanced than to this. Means we have the one that is a rapid hardening cement and the another one that is the extra rapid hardening cement. It is obtained by mixing the calcium chloride. But the thing is that it should not be exceed 2% by the weight of the rapid hardening cement with rapid hardening cement. Now, addition of CaCl2 imparts quick setting properties. It also imparts a quick setting. It is also have a quick setting time. It is also have a quick setting time, but it has more than that of the quick setting times. Yeah, it is suitable for the cold weathers. I will just make a space for this so that I can write. Yeah. So this can be used in the cold weather construction. In the cold weather constructions, because it accelerates the setting hardening, and its 1 and 2% strength is more than the 25% strength of the rapid hardening cements. And yes, when we are going to talk about the maximum time of using this cement is 20 minutes for mixing, transporting, placing and compaction. It means when we are going to mix it, then we need only 20 minutes to mix, to transport from one place to another place and place, and the placing of that cement and the compaction factor. Next, move forward for the low heat cement and Portland blast furnace slags. Now, this is obtained by reducing the rapid hydration compounds. As per the Indian standards, as per the Indian standard specifications, the heat of hydration of low heat cement will be for 7 days, not more than 65 calories per gram. 28 days, 75 calories per gram. Since the rate of the gain of strength of the cement is slow, hence adequate precautions should be taken when it is used. Now, the next one is Portland blast furnace slag cement. This cement is made by intergrinding Portland cement clinker and GBFS. Now, the next one is acid resistant cement, and acid resistant cement is composed of the following. Aggregates, it composed of the aggregates such as cards, and some additives are also there. Then the sulfate resistant cement, it is good for the long term exposures, for the durabilities of this. Now after that we have the colored cement, that is a white cement. It is the process of manufacturing white cement in the same, but the amount of iron oxide which is responsible for greyish color is limited to 1%. As if we have also discussed that iron oxide is used to give color to the cement. So for white color, that is only the responsible for this one. Grey, and the whiteness should not be less than 70% on the IS scale. Now, there is the next one is the quick setting cement and machinery cement and super sulfated cement. Quick setting cement is in the manufacturing of this, gypsum content is reduced to get the quick setting properties. Also, the small amount of aluminium sulfate is added in this type of cement. Now, the next one is the masonry cement. Masonry cement is consists of the mixture of Portland cement or blended hydraulic cement and plastering materials. This cement is used for the masonry work, plasters, and this cement is not used for the concrete work. Now, the next one is super sulfate cement. It is made from well granulated blast furnace like 80 to 85%, and calcium sulfate is 10 to 15%, and Portland cement is 1 to 2%. And this cement, it should not be used in the place with temperature below 40°C. Now, the next thing is that we have covered the types of the cements. Now we are going to tell what are the types of the cement tests. So there are the three types of tests: physical test, chemical test, and the mechanical test. Now, when we are talking about the physical test, we have to move forward for the field test of the cements. So in the field test, we have to first see that what is the color of the cement. As if we know, and we have discussed in the earlier slides, that the color of cement, it be a gray with a light greenish shade. The next one is the what are the physical properties. If it has to be a very fine and it has to be a very smooth. When we are going to rub with the hands, it feels very smooth. So, or the another test we can do in the field, that is if we have a bag of cement and we put our hand in that, we have to insert it in a bag or a heap. It should be feel cool. If it doesn't feel cool, then it means the cement is not good. And the another one is, if the small quantity of cement is, if we are going to take the small quantity of the cement in the bucket full of water, and we should throw in it, and if it is sink, it has to be sink. It should not have to be float on the surface. If it is a sink, then it is a good. And there should be the no presence of lumps. Lumps means ऐसे छोटे-छोटे टीनी lumps उसमें नहीं होने चाहिए. Now, the characteristics what I am talking about, the fineness, the setting time is a crucial point, and the soundness. Soundness refers to the ability to maintain its volume. As if I also said that if it is in the excess, it makes cement unsound, right? It means it will be changed in the volume. Now, what are the applications of cement? Means where we are going to use this cement. So it is used in buildings, it is used in dams, roads, foundations, bridges, sidewalks, pipes, and precast structures. As if we can say that it is used in all the era of the constructions. As I have already talked about that when we are going to use a mortar, it is in the form of mortar, in concrete, in RCC. When it is with cement and sand, it is mortar. When it is with cement, sand and aggregate, it is concrete. When it is with cement, sand, aggregate and rebars, then it is termed as reinforced cement concrete. The last, emerging trends in cement technologies. We have to move forward for the sustainable cement. Means, as if I have already discussed that it is responsible for the CO2 emissions. Cement causes CO2 emissions. So for this we have to make a sustainable cement so that it can reduces the carbon footprints. So we can use recycled material. As if IS code also says that we can use 30% of fly ash to make the concrete. So it can be, we should have to go for this sustainable cements to reduce the global impact of CO2 emissions caused by the cement. And the functional cement. Functional cements is like a cements with enhanced properties like self-healing, thermal insulations, energy storing capabilities. These types of are the emerging trends, technologies we are going to use in the cements. Now, the another digitalizations. The more and the more are in the uses. The use of advanced technologies such as AI and IoT to optimizing the cement production. How can we are going to optimize the cement production? As if we are going to prepare a concrete, then we can partially replace the cement with the other pozzolanic materials. Then we can control the quantity of the production of the cement. That is all about the today's lecture. Now furthermore we are going to discuss some another next type of material in our next video lecture. Thank you.